So we're going to start talking about the systems. Heating systems we'll spend most of our time on. We're going into the winter season now, so it's on our minds. Cooling systems, primarily if you get to it on a fundamental level, cooling is just happening in the opposite direction. So heating is you're moving heat around, transforming heat and moving it from one place to another. Cooling is just the reverse. So in the summertime, when you want to cool things, you're just taking the heat from inside the house and sending it outside the house. So it's the same kind of concept, at least on a fundamental level. Then we'll also talk about hot water. And so we'll look at the systems, basic categories of systems, enough to get your brain in that mindset where you're considering different technologies and options. We're not going to be able to touch on every type of product that's on the market today. If you walk through any big box store, Lowe's, Home Depot, whatever it may be, you'll see a number of different technologies available. And we'll just kind of touch on some of those and look at some of the pros and cons of each and hopefully get the ball rolling if you're considering some options. Maybe you have a system that's over 10 years and you might want to replace it, or it's not working as efficiently as it could. So we'll look at some considerations there. And then we'll talk about some of the operations and maintenance and sizing and for the systems. And then towards the end, before we take questions, we'll talk about some of the financial analysis that we can do and how we can kind of see what the bottom line is for fuel cost and equipment cost. So I shared this information, I believe 2 weeks ago when we talked about home energy use. Now this is electricity, okay? This is electricity. And I wish I had shared a different chart here, but I do want to point out this is electricity, but most of the electricity in homes here in the US go towards space cooling, heating, and water cooling, 16, 15, and 12% respectively. So those are the three areas we're really going to address today, how we can save money in each of those areas and save energy in those categories because they take up the biggest part of your electric bill, as well as if you're on natural gas or propane or any other fuel source, you're using a lot of that just for heating. Now, I also shared this information with you last time we talked about energy auditing. Just as a quick review, we're going to focus on those lower tier levels like conservation and efficiency. Towards the top of this priority diagram, we see renewable energy, things like geothermal technology and newer renewable energy systems like solar. We're not going to spend as much time talking about that today. We'll revisit that in a later session in December, but we're going to look at these lower tier levels, auditing, conservation, efficiency, because they have the best return on your investment. And conservation is really just a behavioral change. And so we'll look at how just changing the thermostat, if we go up to the wall and we change the dial of our heating system this winter, we could save a significant amount of energy and conserve it by just a simple action where we're not actually spending any money to do that. We're conserving it just by turning the dial on the thermostat. And so we're going to focus on some of those techniques before we get into the higher cost systems. Okay, now just to cover a basis of what heating systems look like, there's really three components, and every heating system is a little bit different, but they all pretty much share these three components. You have the heat source that's generating the heat. So it could be a furnace, a boiler, or any of the other systems we'll talk about today. You have a distribution center that then spreads that out to the house. It could be to, a zoned area just in one bedroom, or it could be through the whole house through air ducts, or it could be a radiator. So there's a variety of options there for distributing that heat. And then you have the control system typically mounted on the wall, or sometimes the device itself, where you regulate the amount of heat either coming into your house in the winter or going out during the summer months. So those are the three basic components. I just want you to be familiar with some of this terminology as we go forward when we talk about the heat source and the distribution system. I'm sure most of you know what the thermostat is, but for others that may not be as familiar with the heat source and distribution, those are the three vital components for a system. So we'll start by looking at heat sources, and I'm not going to go through every last detail, but I'm going to share some of the main types of heat sources. Furnace and boilers are fairly common here in the state. We've got furnaces that move heated air, and boilers, sometimes confused. You know, a lot of times people get furnaces and boilers confused, but furnaces move the heated air and boilers move a water or a liquid steam. And so if you're wondering whether you have a furnace or a boiler in your house, you can go down and look at it and see, does it have a big air duct coming off of it? If so, it's a furnace. If it has water pipes coming off of it, it's probably a boiler. There are also heat pumps. Again, those are highly efficient, and we'll really dive into efficiency ratings a little bit later this afternoon. Electric heat systems, there's a variety of options. There could be small space heaters. You could have electric baseboards and a number of other technologies with that as well. And then active solar, you're not going to see active solar as much. And this is different than solar photovoltaics. What many think of when they think of solar energy is solar photovoltaics making electricity. But what we're talking about here is something very different. Active solar here is using a solar collector to collect heat or thermal energy. And so that's really what we're talking about mostly today is thermal energy. Now, the electric heaters that we just talked about here on the slide, electric heaters take electricity and turn that into heat. So really what we're doing with any of these systems is taking one form of energy and turning it into heat. Same thing with active solar. We're taking thermal energy from the sun and transferring that rather to a water or something like that, or space heating. So we're really gathering that with a solar collector, not an electrical collector, but a solar thermal collector. Okay. And so again, we'll revisit the efficiencies of some of these systems, and each of these has some pros and cons, and we'll kind of navigate through some of this momentarily. But I do want to remind you, if you have questions at any point on any of these types of systems, go ahead and type that question into the Q&A, and I'll do my best to address those a little later. But I do want to make sure we kind of highlight some of the differences between these systems. Again, a furnace and a boiler, they are different. One is working with air, that's the furnace, and the boiler is working with a fluid. And so if you can make out those photographs there in the top corners, you can see, as I mentioned, a duct work coming off of the top of the furnace, and that's taking air, the distribution system, taking that to the different areas of the house. On the right-hand side is those pipes coming off of the boiler. Okay, and you can use any number of fuels for both of these systems, the furnace and boiler. It could be natural gas or propane or a number of other systems. The electrical systems have different efficiencies. I've even heard of electric boilers, but I don't think those are too practical. You can correct me if I'm mistaken on that, but I haven't seen much on the electrical boiler side. They do, well, I'll talk about efficiency later. I was going to get ahead of myself, but that's the basic idea of that. With the furnace, I'll just say one additional thing as we talk about some of the maintenance. Typically with most of these systems, you're going to have a service contractor come out. You know, I'd recommend once a year to do a tune-up on these systems. There are some things that you can do with the furnace, like replace the air filters and stuff like that. If you're handy enough with that, you do have to be cautious in working with any of these systems. I think that goes without saying, but there are some maintenance involved in both of these. And again, that's something we'll touch on later as well. Heat pumps, and there's a variety of these systems, so I can't just say there's one efficiency rating for any of these systems because there's so many different technologies out there, and heat pumps, as you can see, are just the same. One of those is the air source, and that takes heat from the surrounding air and transfers that heat inside. The geothermal or ground source heating system pulls heat from underground. So if you have a constant underground temperature, maybe around 55 degrees when you go down about 6 feet, for most parts of the state, we have that constant temperature at that level. You can use that heat and transfer it to a closed loop system. It could be water and glycol running through those underground pipes. That water glycol mix absorbs the heat in a winter and transfers it into your house. And the air source works the same way. You're just having similar to a central AC system. And again, remember, these systems can go forward or backwards. So a heating system, a heat pump can work in both directions. It can have a valve that switches back and forth between heating and cooling. It might be more efficient in one season rather than the other, but that's some of the idea there. So all of these systems will work in both directions. And the more popular now and growing in popularity are those mini split ductless systems. So you have the air handler up high on the wall typically, and then the condenser unit goes outside. So you have that quieter system, it's outside, and then you have a little small air handler that's actually mounted in the house. These are heat pumps as well that can work for heating and cooling. Again, it might work different depending on the season, but that's the basic idea behind those systems. They are extremely efficient. We'll see that as we look at the efficiency ratings for some of these systems. They can be quite expensive, especially the geothermal systems. You're digging up underground, whether you're doing horizontal, you might need a lot of land for that, or if you have to go vertically, you could be going, over 200 feet deep with those. So the cost can add up for these systems quite a bit, and we do want to look at the economics to make sure that pans out. And there's other benefits to using the system as well, but those are some of the considerations there. You can see a diagram there, a difference between heating and cooling. Again, it's just working in reverse. And so you get the benefit of both. So, in many houses, you might have a central AC, and then you might have a separate electric baseboard heating system if you're all on electrical. But these heat pumps provide the benefit of both. And in some cases, you might need supplemental heat, depending on what type of system you have. But for many cases, you can get by with one system. Again, solar heating, just to briefly reiterate, solar heating is not working with electricity. You're just gathering the heat from the sun and passing that through the house. You could use it for water heating, and we'll look at that application later. Or you can be using it through radiators to give off heat in the house. Okay, so the left-hand side is passive heating, and that's just when you get sunlight through your window, for instance. But active heating, you actually have to have what we're talking about is equipment installed on the roof or elsewhere, a solar collector that absorbs that heat, and you have to have a fan or a pump that moves the water, the mixture through the house and to a radiator or something like that. So that's an option as well. The cost for these can be fairly high, but there are some other benefits to it as well. There's also the smaller space heaters, the wood and pellet stoves, especially the newer EPA certified stoves that have very low emissions. They can have very high efficiencies. And if you compare that to, just using a regular fireplace, which may only have 10% efficiency, you lose about 90% of heat in a fireplace, a traditional fireplace. More if your chimney has not been swept or cleaned lately. There's also the portable and direct vent walls. I don't see too much of these outside of commercial or sometimes multifamily housing, but those are around as well, and they do have some benefits. Most of those portable systems are electric, and there's various options, and I think we'll look at some of those momentarily. But those are some other options there, and they all come with their pros and cons. And again, I'll share some of this information with the resources, and when the video is posted, this recording will be posted within the next week or so. So if you want to look back on any of this as well, it'll be made available. Now, the distribution center systems, again, we've only talked about the heat sources. Now we'll look at the distribution. How does that heat now get spread out to the areas that you want? One of those is a forced air system, and I think a lot of people had that when I issued the survey there at the beginning. A lot of people are working with forced air systems. In any sense, what that is you have those big air ducts that go through your house. So we'll talk about the central AC units and heating systems. but that's where you have those air ducts running through the house. You could have a radiator system, steam radiant. Don't see those as much anymore, but they're still around. Then there's the variant of that, the radiant heating, which could be installed in the walls or in the floor for a nice, comfortable heated floor, something like that. That's typically in new constructions. It'd be difficult to retrofit a system with that. And then there's two types of baseboards. There's hot water baseboards where water goes through it, and there's electric that's working on electrical resistance, and they're both very efficient. Really just depends on the specific system, but you could have 100% efficiency with some of these, the electrical resistance, for instance. And so there's a lot of benefits to those as well, but just so you're familiar with some of the distribution options out there. Now, we can kind of say almost the same thing about the air conditioners. Remember that heating and cooling is very similar, just kind of on the flip side. So most of these systems work in a very similar way with the cooling systems that we're talking about now. So I'm not going to spend as much time on those. Four main categories that these come in are the central air conditioners. You see that big condenser there at the top left. That system is outside your house, and then that cooling gets pulled inside. You could have a smaller window unit or portable AC unit. I use those in the summertime at my house. They come in various efficiency ratings. They're pretty low cost. You don't have to have air ducts and anything like that. There's the downside of the more noise level. You could have that window unit making a lot of noise in the room. So there's some other downsides to it as well. Efficiencies are a little bit lower. It's going to be different because you have air ducts with the central system, whereas a room air conditioner, you don't have air ducts. And so you might have extra additional losses as air goes through the air ducts, especially if you have a leak or something in your air duct, you can lose efficiency that way as well. Again, there's the ductless mini split. We've already talked about that in terms of the heating system, but here it is again for the cooling application. Okay, these systems are rather expensive, and really from a personal standpoint, that's what it came down to for my family, is opting for the window units over the mini split system, which could cost a couple $1,000 depending on the size and design and parameters put forth by your demand. And then there's other systems, portable and evaporative coolers. We're not going to spend as much time talking about that. Works best for drier environments. It could work somewhat here in Maryland, but I think for a lot of areas, really too much humidity in the air. But those are an option as well if you want to investigate some of those. So those are some of the cooling systems, very similar to the heating systems, but just some other options there. Now, hot water systems, we'll talk about a couple options there. The most common for most of us is probably the storage tank. So on the far left, you'll see a storage tank option. Pretty inexpensive, pretty standard, works on a number of different fuel sources, whether you're on electrical or natural gas or something else. There are the on-demand tankless systems, and so that is something that has a higher investment, but it does have its benefits. You're not storing water in a tankless system. It doesn't have a tank, and so you don't have losses of it just sitting there. With the tank system that I presume most of us have, I have that in my home. The tank has standby losses just because it's always heated up, and you're going to have losses over time. The on-demand system, it's limited more by the flow rate, not by how big the tank is, and it can use a lot of energy during that heating process, but it's only while you're using the system. So there are some benefits with that. The heat pump, again, could also be used with water heating. Same kind of information I shared previously, very similar. And you could use it with the geothermal. You could have an electrical system or anything else there. There's also the solar thermal. We talked about that. So again, having a solar collector on your roof to collect heated water. And then you could have some variation there. I've included tankless coil and indirect heaters, coupling that with a boiler, for instance. And so if you're already using a boiler or something of that nature for heating your air, then you could couple it with a water heating system. And so you get some preheating in the least, or not wasting some of that energy. So you're getting both of those. And so you'll have a coil of water going through the tank. And so you're not getting space heating and water cooling at the same time. So there's some benefits there. It is expensive. It is finicky to couple those systems together like that. It does require some additional service because you're using two systems. I've heard bad stories about it, but I think it does have possibilities and opportunities to see some energy savings there, coupling different systems together.